Hi guys, so today we're going to apply the power rule to find derivatives. Just kind of make a note, make sure that you know the difference quotient because while the power rule is a shorter method to find derivatives, it is chapter 2 of calculus, whereas the difference quotient will be chapter 1, and there is a tutorial on the difference quotient as well. So a couple of notes for the power rule. Make sure you are only using it if each term only has one variable. So 5xy has two variables, so that won't work. The variable and its respective power must be in the numerator. So if you look at number 1 and number 2, we're going to have to fix that. And to actually apply the power rule, you're going to multiply the coefficient by the power and then subtract 1 from the given power. So if you note for the first problem, we have f of x equals 8 over x squared. So since the variable and its respective power is not in the numerator, we're going to move it from the denominator to the numerator by switching the sign. So instead of 8 over x squared, it's going to say 8x to the negative second power. And then another important factor to remember, whether you're doing the power rule or the difference quotient, is that we don't actually substitute the value of x in until we fully find its derivative. So in order to apply the power rule and find the derivative, this notates the derivative, we're going to multiply the power times the coefficient. So multiply the coefficient by the power. 8 times negative 2 would give me negative 16. And then subtract 1 from the given power. So we're going to subtract 1 from negative 2. So negative 2 minus 1 would give me negative 3. So that is going to be my new power. And back in algebra, you guys learned never to leave a power negative for your final answer. So we're going to fix that. Now keep in mind that the negative 3 only belongs to the x, unless it's completely in parentheses, which it isn't. The negative 3 will only belong to the number or letter closest to it. So that's why the negative 3 only belongs to the x. So this would give me negative 16 x to the third power. So from here, since we fully found the derivative and corrected the negative power, now that we have that, we're going to replace the x with the 2. So from here, we found the derivative. Now to find the derivative at x equals 2, we're going to replace the x with 2. That'll give me negative 16 over 2 to the third power. So negative 16, exponents come first in PEMDAS. That never goes away. 2 times 2 times 2 gives me 8. And negative 16 over 8 would be negative 2. All right, so same thing for the next one. We're given a function, g of x. So we have 1 over x to the first power. So remember that it's in the denominator. We need to move it to the numerator, so it becomes x to the negative first power. There is a 1 here still. That 1 from the numerator hasn't gone anywhere. But remember, if you don't see a coefficient in front of a variable, there's always a 1 there. So I'll keep it there just, for simplicity's sake, but just kind of note that. All right, so from here, we're actually going to multiply again, applying the power rule, multiply the coefficient by the power. Negative 1 times 1 is a negative 1. And then x, we're going to subtract 1 from the given power. So negative 1 minus 1 is negative 2. And same deal, we do not leave a negative power in our final answer. The negative 2 only belongs to the x. So we're going to keep the negative 1 in the numerator. And x squared moves to the denominator. This is our derivative. And now they want to find the derivative at x equals negative 2. So the derivative at x equals negative 2 means that I replace the x with negative 2. Always substitute in parentheses so that your exponent is also properly distributed. If I square a negative, it's still going to be positive. The negative 1 in the numerator, though, moves over, and negative 2 squared would be 4. And that's it, guys. All right, I hope this helps.